So in this video I'm going to just run through some practice problems with the proving trig identities. So first of all, I just want to remind you that these are not proven equal. We're trying to prove that they are equal, so we can't assume this is the equation, which means we cannot do things across the equal sign, like add the same thing to both sides or multiply the same thing to both sides. We can only work on one side at a time. If you watched the video before this, it talked about some techniques we can use, like changing everything to sine or cosine, or changing everything to the same trig function, and then a bunch of different algebra techniques. And so now I'm going to employ those and just kind of run through some examples so you can get a feel for this. This is number 4 on the worksheet, which is available on Canvas, so it's a good idea to print off that worksheet and maybe try this before you watch the video, or watch the video and try it afterwards, or whatever works for you. So on this one, I noticed that I have one term on the right side and I have two terms on the left side, which means it would make sense. There's no way these can be equal to each other as long as I have two terms and one term. And since it's hard to change one to anything other than one, really, definitely not to change it to two terms, so it makes sense to work with this side of the equation to begin with. So I'm going to go ahead and do that, and since there's secant, cosine, cotangent, and tangent, it makes sense to change everything to just sine and cosine. That way it'll be easier to cancel some things out and so forth. So secant is the same thing as 1 over cosine, and of course cosine is already cosine. And then tangent is sine over cosine, and cotangent is cosine over sine. Now I'm not saying this is the only way. I'm not even saying this is the best way to do this. This is just one way to go, and that's kind of the way you have to do these, is you just come up with an idea and try it and see what happens. So now these can be simplified, because I have a fraction divided by a fraction, if you will. If we put a 1 over there, you can see that's a fraction. So when you divide a fraction by a fraction, you flip it over and multiply. So if I flip this over and multiply, I'm going to have 1 over cosine times 1 over cosine minus, and this is going to be sine over cosine times sine over cosine. I'm going to make this pen write a little bit thinner. Okay? And of course that equals 1 over cosine squared, and that equals sine squared over cosine squared. Okay? So we did some good maneuvering here. They have a common denominator now, so we could add those together. So that would give me 1 minus cosine squared on top. I'm sorry. Whoops. Maybe I'll come over here. 1 minus... come on. 1 minus sine squared on top and cosine squared on the bottom. Right, because I have a common denominator, I can just add the tops and the bottom stays the same. But then if I know my trig identities, I recognize that 1 minus sine squared is cosine squared. So this becomes cosine squared over cosine squared, which is 1. And I think that's where we started, wasn't it? Yep, there we go. So you can see we just worked with one side until it became equal to the other. Okay? Let's try another one here. Here's a cosine squared y minus sine squared y equals 1 minus 2 sine squared y. So what are my options here? They're already in sine and cosine. So in fact, it's almost all sine. If I change that cosine to sine, then I'd have nothing but sine. So that seems like a good maneuver. So if I look at my identity sheet, I realize that cosine squared is the same thing as 1 minus sine squared. Of course, that's still sine squared there. And when I do that, obviously I can just add those two together, and I get 1 minus 2 sine squared y. And oh, what did I got? I already got it. That was a quick one. Okay? Look at this one over here. This one, we got a cosecant squared times tangent squared. Looks like we have a lot of tangents here. The problem is that cosecant squared doesn't change easily to tangent. So I might just go with sine and cosine. Although I could change cosecant to cotangent, which is similar to tangent. But I think I'll just go with the sine cosine for now. So if I change cosecant squared in terms of sine, that would be 1 over sine squared. And of course tangent is sine squared, and that looks good right there because those are going to cancel out, over cosine squared minus 1. Notice I'm not touching the right side, just leaving it alone for now. And then those sine squareds cancel out, and I'm left with 1 over cosine squared minus 1. Of course, if I know my identities, 1 over cosine squared is secant squared, isn't it? And why is that good? Because that's another Pythagorean identity. Secant squared minus 1 is tangent squared. So I can change that to tangent squared. Okay? In case you're wondering where all these identities are coming from, I mentioned this in the other video, but let's go back up to modules real quick and look inside there. Modules under the analytical applications of trig. Nope, under analytical trig. The trig identity sheet. If you pop that open, here's all those trig identities that we're using. So far, we're really only using these guys down here. These are called the Pythagorean identities. We'll get to the other ones later, but this is really what we're using right now. So let's hop back over there. So you should have that page printed off also. Okay. So here we'll grab another one, like maybe, yeah, we could try that one. So here's another one. We got nothing but secants there, so it seems like we should be able to do something. Although, yeah, we could, yeah, we can't change that to secant. So even though these are all secants, they don't, there's no way to really simplify that. We could break that into, no, we couldn't even do that. So I think I'd change everything to sine and cosine once again. So this would be 1 over cosine squared on top, and 1 over cosine squared theta minus 1 on the bottom. And again, I want to emphasize there's other ways to do all of these. So if you do it a slightly different way, as long as you're doing correct steps, you're not making up any new identities, and you're arriving at the correct solution, you're fine. And you can't go across the equal sign, which means you can't cross multiply or add the same thing to both sides or anything like that. So, so let's see. So in order to simplify this fraction, I need to combine the bottom into 1. So I'm going to rewrite this as 1 over cosine squared over 1 over cosine squared minus cosine squared over cosine squared. So 1 is the same thing as something over itself, so I can change that to anything I want over itself. So notice now we have a common denominator. So this will be 1 over cosine squared on the top, and I'll have 1 minus cosine squared theta over cosine squared. Then if we flip that over and multiply, we end up with 1 over cosine squared times cosine squared on top, and on the bottom, 1 minus cosine squared, we know that's the same thing as sine squared, isn't it? So there, the cosines cancel out. I'm left with 1 over sine squared, which is the same thing as cosecant squared. That is what we were trying to get. Yep. So there's some examples of doing these. If there's one that you're having trouble with on the worksheet that you'd like to see done, send me an email and I'll be happy to do just post another video. But hopefully this will kind of give you a little more kickstart in getting these done.